Okay, there's one last thing that I wanted to share with you when discussing Prolog, and that is something called cut. So cut is a way of telling Prolog that you want to stop the backtracking and recursion because you've got an answer and you're good to go. So I want you to consider this sample notes that I have. These are from my own personal lecture notes about how member works. Now remember, member has three possible resolutions of the rule. One is something is a member with itself, something is a member with a head, or something is a member with a tail. So we're trying to resolve that. So in this example, we're looking at a situation where we have, we're checking to see if A is a member of AB. So first of all, we're going to try member AB and see if that's true. Member A, comma AB and see if that's true. So this would be the equivalent of doing member XX. Well, since A is not equal to AB, that's going to fail. The second thing that we're going to do is we're going to try to match the first argument, X, with the head of the list. All right, so in this case, we're going to try to match A with the head of the list A, and that's going to turn out to work out just fine. All right, when we try to match A with A, we try that first member rule of XX, and we reach our goal state. So X equals A. So we're good. But we're not done because we have to keep trying all the possibilities until we've resolved all the recursion and backtracking and unification necessary to make this all work. And so we're going to try to resolve A with the head of the list that's just basically like the atom A. That's going to fail because you can't get head of something that's not a list. Also, we're going to try to resolve A with the tail, and that's going to fail. So there are two failures. And then we're going to then take a look at A with the tail of the list. Then we're going to look at A with the tail of the list, which is just the list B. So that's this final check. And that's going to require, again, checking member A with seeing if A is equal to the list B. A is equal to the list B. That's going to fail. If A is a member of the head of the list B, that's going to fail, but it involves even subsequent recursive calls to member. And then A is a member of the tail of the list B, and that's going to fail, and it will require subsequent recursive calls. So even though we found goal fairly early on, we still have all this arguably unnecessary work that has to be done in order to completely resolve member through recursion and backtracking. Now, that stuff is there for a reason, because if we didn't find a good match early on, we'd want to keep going through the backtracking recursion for member until we get a valid result, or until we've exhausted every possibility. But it would be nice if we reached a goal state early on to just stop all of the recursion and backtracking. All right, and there's a way to do that using something called cut. So the algorithm is this, works like this. Since we know that there's three things that we're going to try for, just get a slightly different coloring here. There's anytime that we're going to resolve member, there's three things we're going to try. We're going to try member with itself, member XX, see if that works, member of X with the head of the list, and member of X with the tail of the list. All right. So if member XX, member with itself succeeds, why bother checking to see head and tail? We've reached a goal state. And if member X head of the list succeeds, why bother checking the antecedent, or why bother checking the rule that tests for member of X with the tail? So we can express that when we write the member rules by doing this. And get the syntax right here by doing something called a cut. And so here's how it works. You say member X comma X. That was our original rule. Our original, I guess it was a relation. And now we're going to do this. We're going to say exclamation point period. What this means is it means stop recursion and backtracking. If member XX is satisfied. All right, and then we're going to do another one, which is member X So this says if X head is satisfied, if this evaluates to true, then stop the recursion. And then finally, we have our original member for tail. All right, so how would this operate? Well, it operates exactly like this. I'm just going to erase all of this. And let's take a look at how this is going to operate. All right, so we have member X, or member A, AB. We're going to test to see if A and AB are equal. That's the member XX. That fails. Okay, fine. That takes care of the self issue. Then we're going to test member A with the head of the list AB. So it's member AA. We know that's going to succeed, but we have to see it actually succeed. So in order to test that, we're going to try 3 possible member rules. The first one is member AA. So in this case, X is A and X is A. That's going to succeed with a goal. As soon as that succeeds, this rule, this exclamation point is encountered. That means cut. That means stop all backtracking and recursion. You found a goal state, just return. And so what we're going to end up with is an X equal to A, and all of the stuff that's outlined here, all of this stuff is ignored because of the cut. We've stopped the recursion. So it's a pretty efficient way of getting your Prolog code to execute if all you're interested is finding just a single goal state. Now, it doesn't work if you want to find multiple goal states. If you put a cut in, you're going to stop all recursion and backtracking, and so you won't be able to explore all possible solutions to a problem. But if you're only interested in just finding one goal state, cut works out very well.